Okay.
So Thomas, you're going to show us your HTTP extensions to our node?
Yes, exactly. So for this demo, I created this global contract. So this is like a global name that I can send messages to the HTTP server that is written in Node.js.
Oh.
And this Node.js server is running WebSocket server. And so the next thing is client application that communicate with this WebSocket. And that's it. So I can start, first I can start this client application. So this is client application and the WebSocket is disconnected. So now I will start the server. And you can see now WebSocket is connected. And also I will start our node REPL, but sometimes it's not working. Okay. And now I can, I have the server. I can send messages from our node to the client applications. That's the whole point. So I can use this special name. And
so you're using the public name WS?
Yes, this is just like a shortcut, just a shortcut to this HTTP special name. Just a shortcut to send HTTP message directly to my server. And this is the address of my server and endpoint. So when I send this message to this channel, this message will be transferred to the client applications over WebSocket.
That's pretty cool.
And I can, I have some special messages that you can send. For example, you can change the color of the background.
Wow. Good work.
And also you can send messages from the client applications to the R node. But for this thing, I need a contract on the R node side to accept this. And because there is no WebSockets on the R node, I'm using long pooling like HTTP long pooling to accept messages in other direction. So when I start this one, I can send messages to R node. And also, when I'm sending these messages to R node, I can go to the bottom. So this is the message from the client. You can see here.
Oh, wow.
But I can also send some more complicated messages that I call a command. For example, I can send R node show blocks. So now I'm executing command on the R node side, and I'm expecting to get the result here.
Oh.
But I don't have any API of R node directly. I'm using like directly call of R node, like a process call.
That's quality.
So what is the exact, so when you like when you click that send button or control enter, then that makes like a WebSocket request directly to R node, or I didn't quite get that part.
Yeah, I'm making a request to WebSockets on the Node.js server.
Oh, okay, on a Node.js server, and then how does
Yes.
Node.js talk to the R node?
So you cannot push messages directly to R node.
Yeah.
Because I mean, you can do it with gRPC, but you cannot call directly some other contract.
Yeah.
This is why I'm using this long pooling connection. I have another endpoint, which I call send, which will not give you a response back. This send will, this is how long pooling works. I'm memorizing the response. So when you hit send here, I'm using the last response. I just return result to R node. And R node, when R node receives this result, one of these true statements, or maybe some of the errors, it will go and make a loop. It will automatically create another request and wait for another message.
Oh.
That's the whole circle.
Oh, interesting. Okay. That's cool. HTTP long polling. Where does that file live?
This is a contract on R node.
Yeah. I mean, like, can I read that code somewhere?
I will make it on GitHub. I don't have a latest version of the GitHub. Yeah, okay, I will make all the modifications on R node and this code here. Right.
Oh, cool. Okay. Oh, yeah. Nice. That's great. Did people dig that at node testing?
Yeah. They like it.
Yeah.
Well done.
Did you do it on testnet? Oh no, it has to have the patched version of our node, right?
Yeah.
Cool.
But you can, for example, take URL as a special command. So you can check R node, the testnet R node.
Oh, nice.
But you can imagine that you can write these things directly in the rholang, for example, to deploy something or because what I'm executing here is a rholang code, so I can do something like that directly. So this is sent to R node and also executed immediately.
Oh.
So in this branch, this is executed immediately. This is the process, and this is executed immediately.
Oh, okay.
You can pattern match on different processes, and you can have like a different commands.
Okay. And so the last like default one is to just execute whatever rholang code was there.
Yeah.
Oh, that's cool.
But I was thinking on something like webhooks that you have, for example, on GitHub. Maybe you don't have to send the real information. Maybe you only need to send, you can now call listening on the name. You can now check this name. Yeah. This is information that you need. You don't need all the information. You just need notification that your data are ready.
And then you're saying, and then actually get the data however you normally would have gotten it.
Yeah. If you like that, yeah.
Yeah. Oh, cool. Yeah.
That's it.
Okay. Can I ask a quick question on the kind of infrastructure side? So can I think of Node.js as just a web server written in JavaScript?
Yeah. My idea.
Yeah, and then WebSockets is just something built in JavaScript on top, or what's WebSockets? The connectivity.
Yeah, exactly.
Yeah.
I'm thinking that maybe the developers for R node don't have to build all of these things inside the R node. Maybe we can have only small library that you can just say, okay, you plug in existing technology and everything is
that makes sense. But in terms of the actual data passing, the clever thing about your app just now is both client and server side are basically written in rholang, and the Node.js and the WebSockets are just facilitating the transfer of data. Is that correct?
Yeah.
Basically got rholang talking
Yes.
to rholang. And I
Yes.
can think of that just as two smart contracts talking to each other. But the clever thing is you're talking client server to the node.
Yeah. And
so I didn't understand the code, but I've understood the concept.
Yes.
Thank you. Great work. Yeah.
Thanks.
WebSockets is a way of having channels on the web. With HTTP, you have requests and responses. Okay, so that's HTTP colon. WebSocket is WS colon, or WSS colon. And this allows peer-to-peer connections on the internet. It's
I'll do some Googling. Thanks for that interjection, Jim. That's that sounds, I didn't know that. I thought we were talking
WebSockets, sorry.
Yeah, I didn't know that either. That's a great distinction.
WebSockets, the distinction is can you push something or not? And this is not small change. Let me show you what. Even if in my very simple example, on the server side, I have something that I call peers, and you need to push to the client's data, and you need to store these connections. So you need to manage this connection somehow. You need to say, okay, this connection is alive, and I will send this information to this client. And this is why I'm calling this broadcasting, because I'm not differentiating between the clients. I'm just saying, okay, for all clients, send this message, and this is like a very simple example. But this shows that if you put this inside our node, you need to manage this somehow. So it would be much better, as Rich mentioned, that we can make just another contract to deal with all these things.
What library are you using?
Sorry?
I'm a little concerned about your use of a public name there. I didn't understand exactly how that.
Oh, I'm using public name, but in the same sense that you are using a name to when you deploy when you deploy something on the blockchain. I'm thinking that you need some kind of way to send something to other name that you can listen and start your outside application.
So Tomislav, the contract that was listening on the public name at WS, that was just a wrapper around like the real HTTP call that you were making there, right?
Yeah.
Cool. Yeah.
So for me, public names are really scary. I have to figure out how you can let other people read and write it.
Oh no, this is just for example. Yeah, just for example. Yeah, this is like the same thing that you are sending a demo channel now when you transfer the reps. So I was thinking that you want to notify your client application when transfer is complete or something like that.
So the main thing is that it's easy for you to listen on it. Is that why would you make it a public name?
I make the public name just so I can easily write this command in the rep, and that's it.
Yeah, it's literally just so that you can use the REPL, right?
Yes.
What's the REPL? Sorry, Go on, Thomas, I've finished.
This shows that you need this. This is the information that is related to a specific client, right? Because you must say to which client do you send this message. So in that sense, you need this information from somewhere. So when client is subscribing to the network must keep this name somehow. I'm not sure how, but.
Well, normally you would use the registry, right?
Well, this is not, well, yeah, the registry can also be used, but this is not permanent connection. This is something like a session. So maybe you can have a contract that accepting WebSockets and, you know, keeping all the users' sessions and everything and delivers the messages.
All right.
Yeah, so it sounds like maybe that contract that was persistent, that always, oh, well, so what part are you picturing? I'm actually not sure if this is still on the, was that last part about delivering the messages still on the topic of public versus private names?
How do you mean?
Well, that's what I'm trying to figure out. I'm still on, Jim was saying, like, you know, he was concerned about the public name just because it's easy for different applications to accidentally crosstalk and stuff. And then I thought I heard you saying that, like, that was not a concern. There's no need to use a public name. It's just a matter of you wanted to do it in the REPL. And then I wasn't sure if the registry comment was still on that same thread, or I didn't quite get the registry part.
Yeah, that was.
Yeah.
So maybe you can use registry for your specific case. Maybe you have registered users and you want to uniquely describe specific clients. But you know, when you connect with WebSockets, you know, you can disconnect, you can connect. You must somehow be sure that the message is delivered.
So yeah, so I'm still not. I lost the thread there a little bit. So what message are you making sure is delivered?
Any message that is not part of the Arnold communication directly. So you need to send to. You need to change the protocol sometimes, right? In some moment, you need to change the protocol. And when you change the protocol, so
Sorry, when you're saying registry, Tomislav, do you mean the thing where you can do like row registry insert arbitrary and row registry lookup, or you mean a different sense of registry?
I'm thinking on that registry.
Oh yeah, that one. Yeah, okay.
Yeah, but I'm thinking about registry only in the sense that you know, you can have some global name that we both understand.
Mm-hmm.
So in that sense, you should not use directly some fixed name. You should use registry. Yeah, in that sense, yes.
Can the registry be segregated in terms of access control to particular contracts?
Yeah, you can make registry how you want.
So you could have just things that you've connected to able to access the items you store in the registry, for want of a better word.
The registry.
Yeah, that's what I'd understood, and I was just thinking from. So your question was from a security perspective. So my understanding was Tomislav wanted a variable that could be shared across these two contracts, running one on the R node on the blockchain and one just on its own client, both able to access it. And I thought your question was about somehow we need a way of locking that down. And I just wondered whether whether you could put variables on the registry that were only visible to certain bits of rholang code, albeit them distributed.
So registry is just for making some public name. and you can say who can access to this name, who can listen or who can write. And registry is the way to make it public. And
Yeah.
that's it. In
So-
that
so- so-
context,
Now,
I get that.
When you make the name public, though, you can bungle it, what they call bungle it.
Ah, I saw that in the code yesterday. I do get registry, by the way. I'm aware what I just said suggests I don't. I do. Carry on.
yeah,
So-
with registry, you're saying that you are the owner of this name. You can say who can read and who can write to this name.
Whoa, wait, is that a recent
Can't
change?
say that. If it's in the registry, anybody can read it if it allows read, and anyone can write it if it's not bungled. If
Yeah, that's right. It's not access control.
it's not access control.
What? Thank you. What
Yeah.
does what does bundling mean? I suspect it's in the name, but could someone say something on that?
Yeah, so bundling, there's two parts about bundling, and the part that Jim was talking about there is that when you have some name, you can make a bundle plus of that name, which means it's like write only, like you can only send messages on it, not receive on it. Or you can make it a bundle minus, which is read only, you can only receive and not write. Or you can leave it unbundled, which is like, you can do both. Or you can do what they call a bundle zero, which means you can't send on it or receive on it. You can just compare it for equality with other names.
I'm thinking Unix read write execute permission ish.
Yeah, exactly.
Mm.
That's actually, that's kind of interesting, actually. If you think about because on any channel you can send or receive, that's like read and write. And then I was about to say there's no equivalent of execute, but maybe that's like comparing for equality. It would be interesting to restrict someone's ability to compare two names for equality.
Well, when we have a write only, that's the way we execute a contract. Okay, so
Yeah. Oh yeah.
the write only can be used in both.
Yeah.
Writing and for executing.
How's it used for executing? And then I'll let you move on. How do you use it for executing?
Okay, well, in order to run a contract, okay, like locker contract, whatever. Okay, what we do is we write to it some tuple. Is that a tuple?
Yeah. It's like a method call.
Yeah, but it's a write to that name. That's all we're doing is a write to that.
I haven't got many examples, but I'm thinking back to Joshy's money. I can't remember the name of it. Your little game, money spending thing.
Oh, matching pennies.
That's the one. Yeah.
I think I misnamed it after I went back and read that article. So maybe we shouldn't get too attached to that. But yeah, the game where you want to both players should.
But it had an execution call, which was sending a write. I think I see what Jim means now. Thanks.
Yeah. So like in a, I mean, I know this is probably your least favorite example based on your intro, but like if you imagine in Java calling a function, instead of calling a function, we're just sending a message on some channel. And if there happens to be a contract, which is like a function listening on the other end, then some call happens and the contract gets executed.
Yeah, there's no other way to run code.
Yeah.
Thanks for clarifying. Sorry, I think I've dragged you all off topic. I'll let you get back. Where were you? Was it Tomislav?
But related to this, what would you say if you are sending a send, for example, and you just when you receive this process, you just drop it, you just run it, right?
Yeah.
I was thinking on this situation, not on calling send as a running. Does this make sense?
Well, say it one more time.
If you sending a send,
yeah,
on the receiving side, you will have a send expression, and you can just drop it. You can just run it.
Mm-hmm.
So for me, this is like an execution, and not really sending. So I'm not sure what do you mean.
I guess we were, if I recall, I was trying to think where we were. We were looking at sending things client to node, WebSocket side, and you'd got a public name, and Jim brought up that it was very public, and that could be an issue. I think that's what we were discussing.
Yeah,
right?
and then so I'm going to just try to show some code here for a second. So Tomislav, you were you were talking about sending a send, right? So let me just make sure I got this right. So like if we've got some new like outer and inner channel. Oh man, there we go. And then if I do like at outer, oh, it doesn't need an at there. But if I do like outer send, and so I'm going to send something here, and then it just turns out that the thing that I'm going to send is itself a send, inner send, and then I guess this could be nil. This is the situation you're describing, right?
Yeah, exactly.
And then okay, and then so let me understood if I got the rest of it. So then you were saying, imagine there's like some for message from outer, then we're just going to drop the message. We're just going to run it.
Exactly. Okay.
Cool. So we have a single COM event here over the channel. Whoops, sorry about that. Over the channel outer. And then what we send is this whole process. And when we get it, that whole process is bound to message. And then we execute whatever message is, which means we send this. And so after all the reductions, all that's left in the tuple space is this, inner send nil.
Exactly.
So then you were thinking this is execution, basically?
I don't know. What is exactly execution? The whole outer send is execution, right? But also when you drop the message, it's also execution.
Oh,
how to look at it.
Yeah. So, well, this is a funny example then, because this one actually like does computation in both senses, right? It does a send and then it does a drop. So what if instead we just did this? Well, now we're back to this star at nil. Like, is that going to do execution because we did a drop? I think in rhoCalc it is, right? This is a reduction.
Yeah, but it's not reduction.
Only COM is reduction?
I think only comments. Yeah.
So I think I was in pretty much on board with the way Jim was describing send as causing execution. It just was with the assumption that there was like something like this here, you know, some kind of persistent listen. And so then like whenever you do a send, it's going to cause some kind of substitution. Well, even if there's no drop in here, we're at least going to be mutating.
But you can look at it on the other way around. You can have sends, and for each continuation, you know,
have another send.
Yeah. You know, you don't have to put sends. You can put continuations. So in that sense, send and receives are the same, right?
What was that one?
They are the same because you can have sends and just adding continuations. You will get called.
How would you do that?
You can.
Yeah. Okay. You know, what I was suggesting really is not that the send causes execution; it's the listen that causes the execution. If there's a send that matches the pattern.
Yeah. Like it takes both.
How would you in a send execute or evaluate code without doing a listen?
I mean, there is no distinction what came first. You can first execute send, and after that you can execute receive.
Right.
Yeah.
So,
You will not know what came first. So in that sense, they're the same. They're just terms in rholang. So you can just
I agree.
put it in file.
The code is actually run in the receive, not the send.
Yeah.
Yeah, it's
you must execute receive it, and you must execute send.
Yeah, so you need both parts, right? Yeah, I think so. I guess maybe the conclusion there is that, like, in order to do some computation, you have to have a comma event, which means you have to have a send and a receive both. And then a good, like, a good working knowledge of this stuff is that a lot of times we're deploying these persistent sends and treating them just like functions. And in that sense, this send here is sort of like calling the function.
Okay.
It's just like a common pattern that emerges.
Yeah. Okay. Yeah. The function is split on two parts, and like this is the part that looks like a call. Yeah. Definitely.
Yeah. Oh, yeah. That's a good way to say it. Yeah. Nice. Okay.
And Rich, you mentioned that you found I think 3 COM events on the Joshy example, which is not completely true.
Okay. Thanks.
Because there are more than 3 matching of send and receives.
So a match of a send and receive is the COM.
Yeah, and then in Josh's example, there is 2 channels that you are sending. So really, there is 2 COM events for each of the action.
Thank you.
Which example was it? I don't think I saw that, chat.
Your example of with this pennies that
possibly.
Yeah. He's right.
Yeah. Thanks. I get from the off-chain debriefs. I got the transactions, because obviously transactions are related to moving coins, not COM events, and we should be looking at COM events. So I was like, "What's a COM event?" And then I was just thinking kind of OO-esque. Whereas now we're actually getting to what a COM event really is in rholang: send and receive matching.
Yeah.
Yep. Thank you for clarifying. It's worth it. Cheers.
Yeah. Well, I'm going to take the share again, because that brought me to another thing to show while we're on the topic. Imagine we have something like this. So like new channel. And then, one simple way to do a COM event is just to do a send. And
that's the nil process, yeah?
Yeah, this is the nil process. That's right. It's written 0 in the paper. Yeah.
Thank you.
And then so like we could do for don't care what from Chan, and then maybe the continuation is just nil. So like that's one easy way to do a COM event. And then you can imagine, like, if we duplicate this send, so we have 2 of them. Even though we have 2 sends, now we're still only going to get 1 COM event, because whichever one of these things has the COM event with this 4 is going to consume it. We can make that persistent, which means the 4 doesn't get consumed, and so then we have 2 COM events.
Interesting. I get that. I still don't quite get the throwing away bit, the underscore.
Oh, yeah. So it also works perfectly fine if I put a name there, like X. So in this case, so let's go back to this sort of simple case where there's 1 possible COM event.
Yeah, exactly. I guess that's what I'm asking is what's actually happening between the brackets on the 4 comprehension.
Yeah.
When you're reading, presumably. Well, I'll let you tell me, because I don't understand. Thanks.
Yeah. So let me help you build up a working knowledge first. In many cases, you're going to see it look just like this. And you can think of it as receive a message on channel, whatever message comes across channel, in this case, it's nil, that's what I sent. Then call that thing X. So bind the name X to this process nil, and then do whatever process is in here. And, sometimes it's simple like that. Sometimes we'll actually do something with it, like on another channel, send X. And so it just attaches the name X to whatever message came in.
Got it. So what you've just written, which is a nice, easy example to understand, you would be sending null on other channel at the end of that.
Exactly right. Yeah.
And if you have an underscore, Jim mentioned yesterday in his Locker app, that I said, can I think of that as a return code? So it's just like, do nothing with it. Don't bind it to anything. Just
exactly.
Just consume the null process being sent on channel, so it's not hanging around waiting for a receive. Is that what's happening there?
Well, we're still going to have, so the COM event is still always a send in or receive, and they always both get consumed. So the send and the receive here are both going to go away and reduce to whatever this process is. This isn't valid anymore because there's nothing, I can't use the variable x because I don't have one anymore, but it could be something like that.
Got you. So that would still send nil on other channel.
Yeah, that's right. But not, yeah, I should do it better.
No, not at all. Thank you. That's really useful. This has been recorded, right?
Yeah, totally. Yeah.
Brilliant. I'll let you move on, but thanks for the time out.
Okay, cool. Yeah, no problem. The one other thing to know is that in general, what's happening here is pattern matching. So if I do something like send a list, then we can.
Yeah, which I've covered with Jim, so no need to go through it. But I'd forgotten that was doing a pattern match because we're in a simple case.
Yeah, right. Exactly.
Right. So in that simple case, because sometimes simple case. So if we go back to say the underscore or the X on the 4, yeah, X will do. Yeah, whatever. How's that pattern matching?
There we go. Yes. Well, so underscore is a special pattern that the semantics are, it matches anything and it binds no names.
Got it.
And then if you do something like a letter or any one of these expressions that
yeah.
This is the pattern that also matches anything and binds the name my variable or X or whatever to the thing it matched.
The thing being a process.
Yeah, one in this case. Yeah.
Indeed. Okay, thanks.
Yeah, no problem.
Show again the 1, 2, 3, then 1, 2, 3, and show the pattern. Okay, well, in this case, it's a list. It doesn't have to be a list.
It doesn't have to be oh, sorry. Yeah, you're thinking of like this one, I guess, right?
Yeah. Okay, so this pattern matches because there's 3 elements. The other thing we did was we used a dot, dot, dot. And that would match 3 or more elements, right? That.
I don't know if that works when you're sending these polyadic sends. It might. This definitely works in other places.
Okay, that's interesting.
I'm not sure that.
So
definitely, if it were a list, that would work. I know for sure.
Okay, I think it has to be a list. You're right.
Yeah, I'm not sure. It might work both ways. Definitely, it works this way.
I had trouble with it.
But you can imagine a very simple example that you can say I'm matching on X that must be an integer or must be a string. So yeah, and if you're sending a number, this will not match. Yeah.
So the second one would match, but the first wouldn't. Yeah.
So you can easily see that this is like exactly you're saying what you are expecting, and if this is not the same, you will not have a complement.
Yeah. I think I kind of get it. There's a load of semantics of various constructions to learn. My only other thought is how much of this is pure row calc and how much of this is it's not row calc, is it? Well, actually, I was thinking about this morning. I didn't get very far, Jim, reviewing your lesson yesterday. But I think basically I'm viewing pattern matching as taking data that exists within the process and manipulating it outside of row calc and then putting it back to continue processing as part of row calc.
That's a really interesting way to think about that.
Am I close?
I haven't thought about it like that, but that seems right, because we're basically doing some kind of computation to check like the form. Pattern matching is like, is this thing of a particular form, and then if so, go ahead and do the row calc thing. That makes sense to me. What do you think, Tomislav?
Well, I'm also not thinking in that way, because you mentioned data, and you're not matching just the data. You're matching any rholang expression.
I guess what I'm thinking is that a process, when it's passed as a name, is kind of like quoted. It's a quoted process, which makes it immutable. And so therefore, in a way, it's a string. And then this pattern matching might let you alter that string before dequoting it.
It's not a string. You don't have to imagine this conversion. You can just directly compare your process and your pattern. They're both the same. You know.
Yeah. So I get
they're syntactically the same.
Yeah. I would also reflect on the fact that the pi calculus by itself doesn't include reflection, and pattern matching is a join operation on the internals of the process received. So we're actually looking at the content of the process, and we're saying it forms this, it matches this pattern. What I'm receiving matches this pattern. Okay, and that's using the reflective capability of, I think, of the row calculus rather than the pi calculus.
And this is actually, if it's pattern matching, it might not be. So if I consider that process, when I said data, I was considering the process as data, and therefore I was quite close to what Jim was saying just now about joining. But in actual fact, the pattern matching just returns a true or false and then continues processing. It doesn't manipulate that process in any way, does it?
No, it's reflective. It's
so I was slightly offbeat.
It's reflective, and it lets you look at the structure of the process that's being received.
And it's almost an academic thing. It doesn't really matter because I think we've explained it. But would that sit as part of the row calculus? Is that referenced in? No, I don't feel it does. So it's a rholang thing.
That's right. Yeah. It's
in order to give us the reflection.
Well, there's reflection in other ways too. So I mean, because we can do stuff like, you know, I could do something like other channel send, or I think this counts as reflection because I'm like making some new process here. Does that count as reflection? Or I don't think the pattern matching is like the only form of reflection.
Yeah. Okay. If you think of a mathematical expression, where you say, or when you think of it, actually think of a reduction or a transform, spacing out the name, where you say, given this pattern or this mathematical expression, it gets transformed into that mathematical expression. Okay, so you're in essence saying, whenever I have an expression like this that matches this, that results in this. Okay, that's a reduction. It's
exactly, yeah. It's as I think of it in terms of formal logic, it's the transformation rules of the grammar, much as referenced in the rholang lectures that Jake did, where we go through the reduction rules of the PyCalc and the reduction rules of the rhoCalc, which is
here we're having a transformation rules that says when I receive this expression or an expression in this form on this channel, then I do this.
And can that be programmed? Because in the lectures, we were almost talking about reductions as kind of like equivalences. It's almost like, well, if this is true, then that's the case. So it was very much to do with the processing. But within the language, can you actually code what transformations are allowed of those expressions?
Jim, I have a question. You said the matching will make transformation. And I'm not sure that I understand what do you mean.
Well, it's
I see matching like a case analysis. You're just saying, you know, if you match this, you go that path. If you match this, you go that path.
yeah. I mean, it's like binding a method signature to a function, right?
Mm.
But mathematically, we can look at that as saying, given this expression sent to this channel, we're going to.
But inside the match, we are not sending, right? We are just matching. We are just saying, you know, we have different paths and we are choosing the one of them, right?
Right. Given that we send this formal piece of row calculus or whatever, okay, which may or may not have type information, may or may not have definite values, could be a variable or could be a constant. If I see x plus 2, or if I see x plus y, something in that form where I have structural equivalence, then if I receive that on this channel, then I'm going to evaluate the scope, or in a join if all the conditions are met. It's like the preconditions to run something.
I think we had three concepts going on there. So I think Tomislav was right. I think we were talking more generally than pattern matching, and you were thinking about pattern matching only, Tomislav. And I think you were right in what you said. And then I think the second thing we had was the way that a process is executed, or more formally reduced when it runs, which is the reduction rules, which are in themselves transformation rules, because you have a long string, which is a process, and then as it gets reduced according to the rules and the arrows, and bang, 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 and it comes down to the final thing. And ultimately, I think ends in the null process. That's how it terminates. And then I was, in the third sense, was I was kind of generalizing again from that and saying, does the row calculus support, does rholang support taking one of these processes and defining your own logic to change it into a different process that could be completely unrelated, maybe, giving you great freedom to write a load of rubbish. But they were, I think, I don't know if that helped, but I think we were at cross purposes across those three different contexts. Did that make sense?
I'm a firm believer in the mandate that code should eat code.
I agree. I think this is the beauty and brilliance of this when I can finally get my head around it. And I'm way behind you guys. But
you know, in practice, we don't take much advantage of the fact, and maybe I still have to wrap my head around on how to take advantage of it. But we basically can at least match. We can look at a process in terms of its parts, and we can see if those parts are what we expect whatsoever. So I mean, in the rholang, when we specify a pattern, okay, that's
It's the most simple example of this. And we return true or false and continue processing, correct?
yeah,
Well,
well,
we return a list of bindings more generally.
unless we have a match.
Sorry, Joshy? Sorry, Jim. Yeah.
When it's not quite as simple as true or false. When you match, you get back a list of bindings. But yeah, you're right. It either matches or doesn't. And if it does, you get a little more information about what names got bound.
What's a list? I mean, I'm aware of binding variables. What do you mean by a list of bindings?
So like if my process that I sent was 1,2 and the pattern that I was matching against was A, underscore, then I'll get back the information that it matched and that A equals 1.
I see. Thank you.
In Joshy example, Joshy have written ABC, so you have more than one variable that you are binding.
Thank you.
And I want to say, you said that reductions will reduce, and this should not be always the case. You can have reductions that expand. This is completely normal, because you're executing continuation, and inside this continuation can be, building the new, completely new chain. You don't have to reduce to something smaller.
I hadn't twigged that. That's fascinating. Thanks for pointing it out.
And this is the only way that you can change the state of the raw VM with this reduction rule. And this is the only one reduction rule that you match, send, and receive. There is no other reduction rules. This is only one.
Yeah, Tomislav, I was thinking about that a little bit. And I mean, I'm agreeing with you on all of that stuff. No challenges to any of that. The only part that struck me as interesting is that COM is the only reduction rule, because I was thinking about the state of the row VM that we have like on a blockchain, and it seems to me like parring in new code should also count as a reduction, or I mean, maybe the word isn't reduction anymore, but it definitely changes the state as we move forward, even if no new reductions happen.
Oh, you mean? Oh, you're changing the state, but you're not reducing anything.
You just part in a new send.
Oh, yeah, you're right.
Something like that.
Yeah, this should be also called changing the state. Yeah.
That would be an expansion.
I agree.
That might be an expansion rule. And
yeah. Instead of reduction, exactly.
When you say the state of a VM, because I get the idea of a global VM. I think I'm right there. And when I think of the global VM, I think of a global operating system. So when I think state, I think of this incomprehensible to humans, massively complex state of code that is then almost like a Turing machine, but distributed across the world. Is that how I should be thinking of it? And you seem to be talking about the state of the VM and relating it to processing of code, which just seemed to be a level of greater comprehension than I've currently got. So could someone maybe say something on that? Try and enlighten me.
So the state of VM is just, in rholang, it's very simple, You just look at the code and serialize this code is the state of VM.
So it's almost like that's a substate of the entire VM, but it's the only substate that you're interested in, is your current context, for want of a better word.
Oh, you mean you're somewhere inside the VM, right? Your code is somewhere inside. Yeah. For me, this is like a perspective for every client that accessing our node. Right?
Agreed. So what you're saying is the VM is in a state that no human's going to understand, though we could maybe write programs that could, but we need to be able to conceptualize that portion of the VM state that our program relates to in order to understand it and program it and input and output from it.
Okay.
Yeah, I'm thinking now in the banking system. We all have bank accounts, right? And
good analogy. Yeah.
So to change the banking virtual machine, you need to follow some of the rules. You cannot, change some money from one account to another just by accident.
Yeah,
so in this is very, very similar. You have.
I think it's simple stuff. I was getting bogged down in nomenclature and definition, but it's actually clearer now. So thank you. Jim, were you going to show something?
Yeah, you were asking before about REPL. And
I was actually. Sorry if I'm monopolizing this, guys. Do let me know if I ever am, because I am behind.
Yeah,
this is great. I love it when we have lots of good incoming questions. We're living great right now.
Thank you. This speaks to the state of the machine. And if we send to 5, let's say 1 plus 1. Oh, I have to put an @ sign here because I have to make 5 a name. It's a process. What am I typing here?
You said 1 plus 1.
1 plus 1. Okay. Whoa, it came out blue. Why did it come out blue? Okay, so, wow. Okay, what this thing is printed out here is the state of the machine, which is really, really busy right now. And it's so busy that I can't, the history is lost. But this is essentially the tuple space. And you can see that this is just a bunch of 4s. These are all the things it's listening for. Okay. There's 1,000,000 4s in here. These are.
Okay.
So if it gets a request,
so is REPL looking at the tuple space or some sort of stack of the VM?
It's just running rholang. REPL is replace and evaluate, or what is it?
Read, execute, print, loop.
Oh, that's read, execute, print, loop is what a REPL is. Read, execute, print.
It just means you can type in one line of rholang and it does it. Then you can type in another line and it does it. So like if you
it's like command line execution.
Yeah.
Right.
Yeah.
And when you run our node, and you can see the same. No, I think you can see the same thing in CryptoFacts, but you'll see the tuple space is just all of the writes that are in tuple space. They haven't been reduced yet. And all the reads in tuple space that haven't been reduced yet. And that's the state of the machine.
Thank you. So tuple space stores everything that's been passed to all the nodes.
Exactly. You just putting you have existing rholang expressions connected with the par, and when you add something, you're just putting another expression in this bag of pars, and if there is a match, you will transform virtual machine on another step.
And then when we
if there is no match, it will just add to all of these existing things, and wait for some other thing that can that can match with this existing data.
Makes sense. Well, it makes sense at the individual node level. I get that. But
How do you mean?
the nodes communicate, right?
Well, one thing to keep in mind, Rich, is this is a good thing to address, but the Rho VM by itself is a concept on its own, apart from being married up with any blockchain or distributed consensus or anything like that.
Ah, thank you.
So far, we've mostly been talking about the Rho VM, and then it's totally worthwhile thing to dive into. But I just wanted to point out this bridge that we're about to cross here.
Right. Yeah. So I was slightly off beat, but now I'm up to speed.
Oh, Joshy have a great point. You can think about of state of virtual machine just by state of your own machine. You don't have to worry about the other machines, because
Yeah, that's what I was thinking.
the way to sync this information to other machines is a consensus protocol. This is the way that
Of course it is.
be sure that that other
Yeah.
the same state as you.
And
So-
this is a consensus protocol written in rholang.
Yeah,
And
or some other way.
it could be, but in our chain's case, it is this way. And I'm thinking that a lot of rholang 1.1 that we were looking at last week, it might well be related to both thinking about Venus and behavioral types and clients like you were showing, but perhaps even more so at the moment is thinking about sorting the problems of Casper proof of stake, making sure that Greg really does address the criticism of Mike Stay with the way that he's got synchronization constraints, which I think is a way of making sure things don't get too far. It kind of forces there to be a check between contracts and join everything together. And one thing I just wanted to throw in there as a comment, see whether you guys agree with me, is probably rholang v1.1 is partly being specified and changed and built in order to help the use case of Casper proof of stake. I don't know if that made sense. And
I'm not sure for that. I don't know, but
yeah.
but I think it will be helpful. But also, current implementation of Casper is not completely written in rholang today.
Good to know. I didn't. What do you know? What it is written in, or
It's part of in Scala and part of rholang.
thank you.
Yeah, and so another part of why I called out the distinction between the Rho VM semantics itself and however we're putting it on a blockchain or getting consensus on it is exactly that Casper issue you're talking about. I still have plenty of hope for Casper. I'm not really even very skeptical about it or anything. But just if it turned out that Casper is broken in some irreparable way, or the liveness problem is really a problem in practice, it doesn't mean we're all the way back to Ethereum. We've still got this really nice blockchain with really nice concurrent semantics. And, so we choose a different distributed consensus mechanism or something like that.
Makes sense.
Yeah. And Greg is talking about of this consensus protocol that can change with requirements, so you don't have to specify all the things in front, and you can have algorithm that can, evolve in something that what we need.
I kind of have faith in Greg plus the community being able to solve these problems. But of course, it is faith. I mean, this is a hard problem, and is it solvable? It's getting to that level of computer science. NP complexity problems, etc. So, but let's hope we can do it. And I think Greg's certainly got the experience that you can respect what he says on the issue.
Well,
Cool.
I don't think this is.
It's impossible, but there's.
Jim, you're saying impossible, or it's possible?
It's impossible. Yeah, I mean.
What's impossible? Sorry, Jim.
Yeah.
Well, you have the FLP impossibility. Okay,
Yes.
Which says
Remind me.
with one faulty processor, you can't have finality and liveness.
Thank you. So what you're saying is we already know that it's an impossible problem, but
Right.
there are ways to maybe make it work in the real world and
Absolutely.
have some get out of jail exceptional conditions to fix the problems
Right.
and then continue.
Look at Bitcoin. Bitcoin is a standing example of something that works. You know, even though it's impossible. Now,
But Jim, you're saying,
in order to have a solution, you would have to prove that your consensus algorithm was invulnerable to all possible games. And we can't define all possible games. There's no method for constructing all possible games. I mean, we can construct all possible games up to some level of complexity, but we can't compose them all. So we will never have a real formally provably secure liveness and finality, and
But at least we're more aware of the limits than other blockchains. We've got a much better place for having this conversation. We can actually say something about it.
yeah, well, we can, and I think that Casper is an approach. It's not the only approach toward it. I think that as more and more ideas come into the playing field, I think the scope of Casper kind of has been increasing and what it covers.
but Jim, do you think that FLP is only impossible if you have if you don't have how Kent was talking about this in his talk in Wrocław. If you have signed messages, you don't have this FLP problem. This FLP is only if all the validators are anonymous. You don't have you don't have a way to prove someone's messages. So it's easy to tamper others' messages. If you have the signature, this is not impossible. This is just a matter of performance.
So Thomas, the important, am I understanding correctly that the important distinction is like without signatures, I could go up to Rich and I could be like, hey Rich, Tomislav said blank, and he has no idea whether that's true or not. It could just be me like bullshitting. But if you've given me a signed message and then I'm like, hey Rich, look at this signed message that's signed with Tomislav's key. He doesn't have to believe me at all. He has
yeah. So you have much smaller surface to mess with the messages. You can keep messages for yourself, but you cannot send different message. So yeah.
This is brilliant, isn't it?
I'm not sure how this relates and what is impossible, what is not impossible. I'm not sure.
What was FLP again? Something liveness and what's the P?
It's author names. I forget what the author names are.
Yes, but Jim mentioned two properties. Thank you, Joshy. What were the Sorry?
Safety and liveness?
Was it safety and liveness? It might have been. What is liveness?
Safety, liveness. Well, is finality part of safety? Finality. So I guess it's the three properties together that you can't achieve. And I don't see how having signed messages would help.
It helps that you can't mess with the messages. You cannot say, You cannot say, I cannot say to Joshy, you know, Jim, send me this message, and I can temper with that and, you know, say something else.
Maybe it reduces the scope within a, you know, because ultimately the row VM as it processes will be a finite thing. So it might be that Jim's right conceptually that even with, or it might not, I don't know, but I think Jim's question was even with signing of messages, so that Josh's example then helps me, it might still be that in an infinite space, you can't be sure of these properties even with that. But it would certainly help to sign the messages because it would reduce the state space of things that could go wrong, which might then help make it more practical and make rholang work in practice, regardless of, I don't know whether the properties would be satisfied or not under the signing condition. Does that make sense?
Yeah, and this guy from Hashgraph, he's talking about this, and he explains that you can make a proof, but not to have completely asynchronous network. So you must have some kind of synchronous constraint in which you can prove that you are safe and alive. But you must have this constraint.
Yeah, I think that's what Greg was getting at the end of our chain debrief 107, which is why I looked it up. I don't know, but you might want to go back and have a look at the last 10, 20 minutes of that. You might be beyond me, but to me, I was reading this sort of thing into what was said there, and I thought he did a little presentation with little graphs, more simplistic than what we're talking. But
yeah, well, no, you can prove. I guess you can prove Byzantine safety and liveness and safety and finality given a time constraint mechanism, et cetera, and signed messages, whatever. But in the real world, we have 1% controlling the 99%, and we have the 0.001% controlling the 1%. Okay, it's not a Byzantine game in general in the world where you're safe if you have Byzantine safety, which is 1/3 of your validators.
You're referring to money as power.
I'm sorry?
Are you sort of implicitly referring to money as power kind of thing? That it's not a fair game?
Right,
Yeah.
which is what proof of stake is about.
Thanks.
Well, wait a second. Contradicting myself here. Like what we have is, we have catalytic effects in complex gaming that we can't rule out that they're all possible games. What can I say?
But we can all understand it better and better through these sort of sessions, and then it becomes a bit clearer.
I guess it's sort of a moot point because of these arguments that Greg and Thomas Love and and Joshy are putting in here, because we can feel fairly secure that the solutions that we're coming up are not only as good as Bitcoin, but they can be better than Bitcoin.
Yeah. Because sorry, Josh, go.
Okay, well, I was going to say, I don't know how long you guys want to hang. Since we've gotten a little bit to how rholang works with consensus, I have concept that I've been kicking around that I very briefly described in Discord. If we want to get to that, I could go. It would probably take 20 minutes or something to generally talk through, or we could defer it too. I definitely didn't want to derail what you were saying there, though, Rich.
To be honest, I think I've kind of forgotten. I think it was related to Greg. I guess to put a thought out there is that. Oh, that's right. I remember. Sorry for divering. So I heard that as part of our testing, 12 weeks without a failure or something, it is what we're going to look at for go live of mainnet, and that was the only thing I think I've heard. Period. I mean, obviously, it's a big thing in the real world, this chain, and there's a lot of different opinions, etc. But it's the only thing that I heard technically that concerned me was that, given what we've just been talking about, going live after 12 weeks of no failure is kind of nothing, given the space of all games out there that could occur. So I have total faith in Greg's maths ability and the development team, and that they're probably catering for this, and that is just a sanity check. But to me, it needs to be a sanity check, not the go live condition. I don't know. I just didn't.
Yeah. Well, see, they're going live with trusted validators, so they don't have to be worried about all possible games initially.
Yeah, got you. They're hardening the network. Let's move on, but I was just throwing it out there. I can happily stay for Joshy's whiteboard session now, or defer it. What do other people think?
I'm gonna have to. I'm gonna have to go. I have a doctor's appointment coming up.
Cool. Yeah, I think I want to start a Lumio poll or something.
I can stick around for another. Yeah, I can stick around for a little bit. I'll just get ready while I'm doing that.
Remember to turn your camera off if you're going to change. Yeah. Well,
all the best, Jim, if you do drop out.
Yeah. No. Or well, what do you think, Tomislav? Are you running off? Should we delay for another week?
No, I'm in.
Oh, okay. Let's do it then.
Yep.
All right. Cool. Let me just flip over here. Share. Oh, that's not it. Oh boy, let's see here. This is the one thing that is a struggle for me. Here we go. So this is basically what I presented at. Well, I sent the link to the video if anyone wants to go there. But the thesis that I'm going to try to get to here is that all of the benefits of UTXOs that we know from Bitcoin, for example, like super easily seeing which transactions conflict with one another, we can gain all of those benefits and still use a process calculus based like VM, so that we get all the oh, let me close that. Okay. So that we get all the benefits of having UTXOs and all that stuff, but still all the full expressivity of having arbitrary computations, and we can even use rholang. And then the second part is that I think it can scale.
Sorry, Joshy. Two questions. One is, where would I find the video? And the second is, what's a UTXO?
Yeah, good question. A UTXO is an unspent transaction output, and that's how Bitcoin works. So basically, like every time you, well, let me answer your other question first. The video I posted on Discord in the rholang collab channel, like I don't know, 20 minutes before we started.
Great.
And then, okay, so let me do the quick review of Bitcoin right here, and that'll do UTXOs. So
sorry, guys. Thanks.
Yeah, no problem. So every transaction in Bitcoin has two things. it has a bunch of inputs which consume old transaction outputs, and then it has a bunch of its new outputs. So just as a simple example, let's say like I have a UTXO worth 5 Bitcoins, and I want to pay exactly 5 Bitcoins to Rich. So my transaction is as simple as it gets. It takes my old output as an input, and then it makes a new output for Rich that has the 5 Bitcoins. You know,
on the next block. Yeah.
Yeah, exactly. That's exactly right, on the next block. And so like a more complicated example might be that like I want to pay Rich 5 Bitcoins. I have 2 different UTXOs, a 3 and a 3, and those add up to more than I even want to pay him. So now my transaction takes both of those 3s as input, mints a new 5 for Rich, and a new 1 back to me as change. So checking for double spends is stupid easy now, because if any transaction consumes any 2 transactions consume the same 2 outputs, that's a double spend. So, so here's a diagram of that. So like, you know, maybe this top transaction up here has 3 outputs. One of them gets respent here, another one here, and another one here. And then all these ones at the bottom, these are still unspent. They're still UTXOs instead of just like transaction outputs. Okay, so that's the idea. And that's one thing that I want to sort of like what's the word? Preserve in this new model. So Ethereum is different. Ethereum makes different trade-offs, right? Ethereum has a virtual machine that's like the one Rich was describing earlier. The state is some like big complicated thing that no one can wrap their mind around, and you try to generally stay to your little area and hope that no one else can mutate your little area in ways you didn't see, and the VM's pretty complicated. And so with Ethereum, we're back to that hard to understand VM, but we've gained all this expressibility and arbitrary computation. So let's see if we can get both. That's what I'm going to try to do. Well, and not that I'm really going to do it. Like Greg did it all. That's like what a rholang is, right? I'm going to pirate that idea. So the next piece is concurrency, right? So Bitcoin lacks concurrency. It's one block after the next after the next. And although they have this thing up here that is a total DAG, a directed acyclic graph, what Bitcoin does is it aggregates all these transactions and jams them into blocks that contain, I don't know how many, but hundreds or thousands of transactions, a bunch of them. And so a problem with that is like, if you consider these 4 transactions here, those 2 middle ones that I circled in blue, we don't care what order they happened in. They can go in any order because they don't share any outputs. But if you aggregate all these things into blocks like you do in Bitcoin, then we're imposing a total ordering over those. And so we're losing all of this concurrency that we would naturally have. The UTXOs by themselves are super friendly for concurrency, but by aggregating all the transactions into blocks, we lose the concurrency. And so we already know about a couple cool consensus algorithms that help us, you know, come to consensus over a DAG and keep all of the concurrency stuff. So PyCalc, this was for the presentation. I think you guys have a pretty good understanding of PyCalc, and so I'm going to skip that part. But here's an important part. We can draw a DAG for these PyCalc terms just like we did for UTXOs. So each one of these blocks here, instead of referring to spending tokens somewhere, refers to the smallest amount of computation we can do in a row calculus or pi calculus model, which is a COM event, like Tomislav said earlier. And then there's this weird thing that I brought up earlier, which is also deploying new code. And that's sort of like in Bitcoin, the what they call the Coinbase transactions, the one where miners get new rewards and mint new coins kind of like out of nowhere. So my outputs look a little bit more complicated now. First of all, they're colored, and the color indicates like what channel something is on. So you can't have a COM between like a pink output and a blue output because they're not on the same channel, for example. And then they also have up and down arrows, and that's just me trying to communicate sends and receives. So with Bitcoin, any 2 UTXOs could come together. There were no restrictions on which ones could go, but with PyCalc now there is. So you can see like in this this blue block right here, it has this like output on the blue channel and this receive on the blue channel coming together, or like a similar thing happens with an up arrow and a down arrow on the yellow channel down here. So that's all fine. So Oh, and the other idea is that once you do one of these transactions, those sends and receives get consumed out of the tuple space. Now, this doesn't fully deal with persistent sends and receives yet, but I have a couple little ideas about that. But I'm going to skip that for now.
Why have you got yellow going to blue? Shall I not worry about that?
Oh no, you totally can. That's a great question, and I've got it happening here also, and I've got it happening here also. And so, oh, and it actually, and here too, it happens in a lot of different places. So the outputs from each transaction can be any color, and they can be sends or receives. And what that means in rholang is that what you write in the continuation after, like, for something from some channel, you can send and receive on any arbitrary channels in there. They don't have to be the same channel that for was listening on. And so in the same way that we've got a yellow block here, yeah, we can do a send on that same channel, or we can do a send on a different channel, or in other cases, we don't have to use the same channel at all. Yeah.
Okay, thanks.
Yeah, you're welcome, no problem. So lining up the color of the inputs is what matters. Whoops, that got a little bit messed up. Let's undo some stuff there.
Can I ask you, what happens with a transaction that you cannot combine in one block with Bitcoin?
With Bitcoin?
Yeah, the whole block is, these transactions are removed from the block and block is created, or the whole block is somehow?
You mean like if it turns out there was an invalid block, like a double spend or something?
Yeah.
Yeah, so in Bitcoin, then the whole block is thrown away. None of those transactions go into the blockchain, but they do go back into the mem pool. So then, like, they can be remined into new blocks in the future, but they're not in the blockchain in any way once the block is thrown away.
So in a sense, you're saying that you don't want to put all the transactions just by accident. You want to have this kind of way of composing related transactions, right? You want to isolate what are related and what is not, so you can just.
Yeah. So what I'm going to advocate soon is that we don't want to aggregate transactions into blocks at all. The whole idea of aggregating them into packages that we send around as one unit is what I'm claiming causes the problem here. So, like, if we extend this back to the Bitcoin model, that means every transaction that happens gets broadcast around like it's block, no waiting for 10 minutes or anything like that. It just happens all on its own. It goes into the DAG as quickly as possible. And that idea actually is inspired directly from Pyrofex and Casanova and Sea Delta.
Cool.
I remembered when Derek came to talk to us about Casanova, that's what he was saying. Like, you just build these things on the DAG wherever they fit as quickly as you possibly can, and then only if there's a conflict, then we go back out and scratch one of them out. But it doesn't have this consequence on its peers, like you were saying in Bitcoin, where, like, the whole block gets thrown away.
I see. This is interesting.
It is. Is Casanova the consensus for Sea Delta? Or
yeah, it is. Yeah.
Cool. I think I read about it once, but obviously I haven't got the same detail. Carry on. Thanks.
Yeah, I don't have as much detail as I would like either. But we have probably the resources, but I haven't studied it quite enough. But I think I like it. It seems really cool.
Absolutely.
Yeah. So okay. Let's see. So moving on then. Yeah, right. So here's that next point I was trying to make. Aggregation throttles concurrency for exactly the reasons that we already talked about. Like, so what did I write over here? Some concurrency is possible with these transactions because the one on the right side, this one over here, doesn't have any ordering relative to the two on the left. Now the two on the left do. They have to go in the order I've shown there because they share a causal link, basically, an input-output pair. But the one on the right doesn't. The one on the right could have happened first of all. It could have happened in the middle between the two, or it could have happened after, and we don't care. But if I aggregate the two that I've boxed in blue into like a single block, now we've enforced that one on the right that could have gone anywhere has to go least. Or has to go last. So that's what we're trying to stop doing. So the solution, I claim, is to make the blocks as small as possible. And I don't mean that necessarily in the way that, like, you know, the Bitcoin scaling debate, some people were like, oh, small blocks never raise the block size. It's not that same kind of thing, because I'm simultaneously advocating that while the blocks get as small as possible, we also totally abolish any timing or throttling or anything like that. So we just like fire them out as fast as we can at all times. And so then the only like limiting thing is how quickly we can get messages around and come to consensus and that kind of stuff. And I wonder, oh yeah, and in fact, so that's like, that's basically the end of it. So the big idea is, I guess, this one right here, which is that I think it would be cool. So like in rholang, in our chain right now, first of all, you can aggregate like multiple whole deployments together into a block. Now, in general, it seems like people aren't doing that. What happens is like deploy, then propose, deploy, then propose. You could deploy, and then finally propose. But even beyond that, even if you just deploy to propose, what our node does right now is it will create a single block that has all of the reductions down to a quiescent state, like until there's no more reductions possible, and sends all of those comms out as a single block. And so I'm arguing that it should be like each individual comm as a block, and then you get a DAG that looks exactly like this one. So, yeah.
Cool. So
I'm thinking.
please go ahead.
I'm thinking of. Is it? Can you split one deploy?
Can you split one deploy? So the deployment itself, the parring in of the code, probably could be a single transaction. Well, in fact, like, you know, this one up here is sort of like a deploy because it comes out of nowhere. Yeah, but then I'm hoping that the comm events within a single deploy can be reduced.
Can I ask a quick question?
Can be split into a bunch of different blocks. Yeah, go ahead.
Deploy and propose. So deploy is signing a piece of rholang and passing it to an R node, is my understanding. What's propose?
Propose is the name of the command that forces an R node to aggregate all of the new deployments it's received, package them up into a block, and send it out for consensus.
Thank you.
Yeah.
Cool. Sorry.
So if you have some code and you want to deploy it, and for example, you maybe you have a simple deploy with 2 comm events, for example.
Yeah.
And
do you mind if I draw this up as we're talking through it?
Yeah. I don't have.
Yeah, that's okay. Yeah, you're thinking through it as we go. That's okay. No problem.
Okay. So if is it possible then that your second comm event succeed, but first is not, and then you are in some
guys? Thank you so much. I'm going to watch the end of this later, but I'm going to have to go.
Okay, cool.
All right. Brilliant session. Learned a lot and really enjoyed it. Thanks, guys.
See you later, Rich. So yeah, so let's see, like here, these ones that are coming up from the like ground symbol, I'm thinking of those as like deployment. So maybe, so let's say we deployed like, I don't know, I can't think of the best way to draw this. So let me try again. I'm starting to get a better idea. So let's say this is like a deploy and it has a bunch of outputs.
For outputs, you mean continuations, right? In rholang terms.
Oh yeah, so we're overloading that term now because output sometimes means like sending a message, but now I mean it in the like UTXO sense. So maybe I'll try to say UTXO. So this thing has a bunch of UTXOs, and then let's say like we want to make a reduction like this. Oh, and in fact, let me get rid of this one. And then another reduction like this. So like I deployed some code that's supposed to have 2 comm events, and then the post state of the tuple space is supposed to have this send and this send left in it.
Okay.
And then if I understood correctly, your question was, can this get hosed up by someone who like does another deploy that looks like this and conflicts and does something like this with a different output. And so now we have like a problem between these two, right? Because they're a double spend basically.
Mm.
Is that the question you're thinking about?
This is also an interesting case, but I was thinking more of something like maybe these two common events, maybe they are not related. This red one and the blue one.
Oh, okay. So yeah, let me keep it. It's useful later.
Yeah.
But I think I can copy it. Oh.
Can you just select it?
Great.
Cool.
That's amazing. I can't believe it. Okay, so let me try again to construct the one. So maybe it's more like my initial deployment has two COM events that can happen concurrently.
Yeah.
And then do they have any relationship at the, like we're quiescent now, right?
Yeah.
Yeah.
And now you can have situation where red one can be finalized, can be accepted, but the blue one will not.
Oh.
So how can you reason about your deploy? What will be your question for the network? Is this part of the code finalized? You cannot ask, is this deploy finalized? Is this block finalized?
Well, you can always ask if we do deploys like this, where deploys are a single thing that have multiple pieces of, so this represents like 5 terms added to the tuple space in that deployment. So we can always ask, is this deploy finalized? But it doesn't mean the same thing. Jim, you're signing off?
Yeah, I made you co-host so you can end this, stop the recording. It doesn't record all day.
Cool. See you later, Jim. Thanks for hosting.
Thanks, Jim.
Sure.
Bye. Okay, but so when you ask in our chain world the question like, is this deploy finalized? It means, did my code go in and has the tuple space been reduced to quiescence? But it wouldn't mean that second part here. It would just mean, did my code go in? So then you have a separate, and honestly, all along, we should have had these separate questions, because with non-deterministic code, you don't just care, has it been reduced? You want to know in particular, which COM events have happened, right? Like if it was non-deterministic, in fact, this pink part over here is non-deterministic. There's more than one valid reduction there. So the most general question is, which of the many possible COM events have actually reduced? And so then we can ask that basically like pair, on a COM by COM basis. We can say, is this one finalized? Is this one finalized? And then we can say like, is this one finalized?
And this is the case now, right? When you want to check if your code is finalized, you must check the tuple space, right?
Yeah, you would have to check.
You're checking the blocks, not the tuple space.
Yeah, currently when you ask, is a block finalized? I mean, finalized always means like, we've formed enough consensus that it'll never be reverted. But the question is like, what is it that might have been reverted? And so in our chain right now, the thing that's finalized, the thing that can no longer be reverted, is the code being deployed and reduced to one of the, in general, many possible quiescent states. Yeah, and then if you want to know which of the quiescent states, then you query the tuple space to see, or you just like replay the execution trace of the block, I guess, is another way.
So what I'm thinking here, can you put this this part of the code in well, you're saying that Hmm. I'm just exploring, you know, what are the possible cases.
Totally. I'm so happy you are. Yeah, I really wanted people at Sub-Zero to do that, but they didn't have enough background to know what the hell I was talking about.
So I'm thinking that is it a situation maybe that you have your deployment and there's lots of code. For example, there are two common events. If this is not too simple case.
Yeah.
And one convent is successful and another convent is not. So validator will try to put it in another block or another transaction. But maybe this is not possible because how can you separate these two things?
Yeah, well, I'm saying there's no concept of try to put it in a separate transaction because they are by definition, this is 3 transactions that we're looking at here. So this was inspired by me thinking about how irritated I was with Greg about bending the meaning of the word transaction. And I was like, okay, so what if we reframe it so that like, even from an external user's perspective, COM event really is like the transaction. Now, probably that still shouldn't face like end users, but at least from an outside the tuple space world, I tried to do that. And so yeah, like this. Oh, and so maybe I should write it more like this. Well, I should write it in the same color, but this is not finalized, could be potentially not finalized yet. So you can get to a state where like this top deploy was finalized and this left com over here was finalized and the right one's not finalized yet. That is totally possible. And it's something that I don't think you have in the current R-chain model. Yeah. So maybe then the question is, are there any negative consequences of that? I guess one is that like, if this thing is not finalized yet, it allows for something like this to come in and happen in the future, where I wanted, you know, the deployer wanted this, I wanted to finalize like this one, and this one, but then because of some wonky stuff that I wasn't foreseeing, instead what got finalized was the same top 2 that I wanted, but also these 2. Yeah, but I would say then like the correct thing, we still have all of the same like unforgeable name guarantees here. So if you don't want this to happen, then you have to use an unforgeable name.
Yeah, I think you're right. If you write your code that has two separate things in one deploy, they are separate things. Yeah. They're not related and. Yeah.
Yeah, so I don't know. I just thought it was a cool thing that would be nice to try. And the other part of it was that I really was interested in what Derek was saying about liveness and Casanova and how, you know, I liked the fact that it was optimistic and everything. And like I was saying earlier, I still haven't fully wrapped my head around Casanova, but like just putting a little bit of faith in those guys who did it, I was thinking like, okay, well, how can we use that on something more like the Rho VM? And I couldn't think of it at first because Derek was explaining how you have to have like, you know, it has to be immediately easy to tell when 2 things conflict like it does when you use UTXOs. But I think we might have regained that and like enabled an optimistic Casanova-like consensus algorithm this way. So
this is very interesting.
So one thing that I was thinking about was like, as a deployer, I have to incentivize miners or validators or whatever to, you know, like pick up these transactions. Like in Bitcoin, that means put them into a block. But really what I care about is that they get finalized in the DAG. So I was thinking about like some way that you can attach rewards to individual COM events. So like if it's important for my application that both the pink block and the blue block here get finalized, then I might like, you know, attach some rewards to both of them. Or if I have some like long running, you know, you can imagine I have a computation that has a deploy up here and, you know, this could get as complicated as we wanted it to, but I'll keep it short. Let's just say there's these 2 COM events and I want them both to happen like that. I have no interest in this thing getting halfway and then no one ever picking up the blue one.
Oh yeah.
Yeah.
No, you just mentioned that you can have this situation in which you can finalize just a part of the coverage, not the whole.
Yeah, and so my thought is we don't want to incentivize validators to do that. So you don't put any rewards on this middle pink block. You put all your rewards down here on the blue one. So if they want to get any of the rewards, they know that they have to go through the pink one to get there, but now they're incentivized to go all the way to the end.
You know what I'm thinking about? That when you have this kind of events, I mean, when you deploy your code, not all COM events will happen immediately, right? Your contract will live inside the tuple space, and he will be transformed. And
Yeah, in general, that can happen.
yeah, you're not talking about situation inside the deployment. You're talking about when other COM events will happen. And
right. Yeah, and you know, you can
I see
imagine a
what you
scenario where I like put some rewards on this deployment because like it's super important to me that this code gets in there right now, maybe to like prove to my counterparty who's also watching the tuple space, like it's in there, it's going to happen eventually. And then I put, you know, and once they see that, then they're going to like, you know, give me the thing I bought or do whatever their part of the deal is. And then they're also assured like it'll get processed eventually. That's why I have also rewards down here. But then like maybe, you know, meanwhile, we've got another deployment that has some stuff going on and suddenly like the rewards go way up. Like this guy's paying a lot more. It could in theory be a long time between when you deploy and when you finally get the quiescent state you want.
Yeah, I was talking about deployments, but this is not really directly connected to deployments, right? You will do deployments as you do it now, right?
Yeah, yeah.
You're talking about in execution. You don't have to collect many COM events. You can just put one COM event inside the block.
Exactly. That's right. Yeah, and so it also eliminates that two-step. I mean, this is not that really important, but it also eliminates that two-step process of deploy propose. A deployment is, you know, that creates one of those blocks that just goes around the network and gets consensus that just adds code to the tuple space. Yeah.
But is it now also possible that you have validator that can, you know, validator that can will execute that will accept, for example, you're a validator, you're accepting new deploy.
Mm-hmm.
And this new deploy is a bunch of codes, and you can have many COM events, but only one COM event happens after this deploy.
Mm-hmm.
Right? This is something that it can happen now. And you can take this one COM event, put it in a block, and say, okay, this thing happened.
Yep. This is a valid production. Update your tuple spaces accordingly.
Yeah. So you're saying why not do this always?
Exactly.
Not in special case. Why not do this always? You're not allowed to put two COM events inside the block. You are only allowed to say for one. Okay.
That's right. Yeah. And so, you know, I also talked in another context about the idea of zero weight validators, but this is another case where I think zero weight validators would be interesting because then I, as a deployer, someone who's not playing the consensus game, but just a user of the network, I can send out my own blocks directly to the network, me as someone who has no weight in consensus, but now I don't need to like have this middleman who might try to act as a censor or a gatekeeper or anything like that. I can just send out my own blocks across the gossip network. They have no value for consensus yet, but I at least make sure that they get around the network in a fair way and without another party. Yeah.
This
So,
looks.
okay. Yes.
This sounds.
Yeah, go ahead. Go ahead.
This sounds similar to Hashgraph, right? They have gossiping about each message.
Oh, yeah, I don't remember. That didn't stick in my brain as well as I had hoped.
Because as I remember, Hashgraph, they don't have like a special validator that you must send. You're just gossiping to everyone. So
Yeah, yeah.
I'm not sure how this works exactly.
Yeah. Yeah, but also I think when we were talking about Hashgraph, we always were only talking about the people playing the game, like the actual validators. Although they were weighted validators still, right? So yeah.
Yeah, I'm not sure. Yeah, I'm not sure.
So, well, I wanted to just share that as something that I think was interesting and might, possibly be relevant at some point in the future.
Yeah. This is especially interesting that you can say how much you will put on some common event. So can validator can choose what is like a more economically.
Yeah, exactly. And I mean, that's how it is in Bitcoin too, right? The bigger the mining fee you're willing to pay, the faster your thing's going to go into the.
Yeah.
And so another interesting example of this, of why this is useful, is like, if we look at this thing over on the left here, and let's say imagine there's like some other code that's in here, like something like this. And so there just happens to be this other path, like, another non-deterministic path that does something I didn't mean to. Like, I wrote my code intending that the solid path that goes straight down is what would happen. It turned out there was some non-determinacy that I didn't even notice or discover on my own. But by putting the rewards all on this block, I've incentivized the miners or validators to reduce it the way I want them to, even if there are other possibilities out there. They have no incentive to go that way because there's no reward for them that way, unless they're involved in whatever the business is.
Yeah.
So.
And how do you think this can be specified, for example, in rholang?
Yeah, I was struggling on that. I hadn't decided if this would be the best thing to add to, like, as a feature of rholang, or if this should happen sort of like outside the protocol as something else that the blockchain keeps track of. It would be nice to be able to do it within rholang, because then we could have all the benefits of using like lots of different token contracts with it and specify rewards in lots of different interesting and related ways and stuff. But then the other part of it is like, that's got to be a language extension to rholang, because if I'm just using rholang to like do something if it's an everyday programming language, like I don't need to specify financial incentives.
Yeah.
The thing that's processing my science data on my,
I was also thinking in a similar sense. If you want to listen on some name on the blockchain, in my example, I want to listen on some name on the blockchain and send the WebSocket message to the client.
Yeah.
So this is also like a difficult to, how can you say in your rholang contract, I need this name for this other code.
Oh, interesting. You mean like a special purpose name, like one of these external ones or something?
No, it's not special purpose. It's just a name inside your deployment.
Yeah.
You want to send something to someone, but not on the blockchain, to some other outside name. How can you specify, this is my special name, or only I can listen on?
Oh, yeah. Oh, well, that's another thing I wanted to talk about earlier that we never really, the thread just didn't get quite back there. I have some thoughts about how the name registry works and how the name registry maybe could work better too. So I think the registry is a super good idea, but it, like we were talking about, it has this like property that it's totally global. And like, once you register something, it's there for everybody. And so what I was thinking is it would be cool to have that's still that exact same registry that works exactly the same way, but in addition, a registry that's uniquely associated with each public key on the blockchain that like is my, you know, we talked a lot about like locker contracts and locker room and stuff like that. So I was thinking, remove the signature verification stuff from in rholang entirely, because we keep making, or I mean, I don't know if this is a part of rholang that you care about, but it's something that's interesting to me that, you know, it has object capabilities basically like baked in, you know, you can treat those unforgeable names as object capabilities. But by doing the like signature verification inside of rholang, that allows any contract to just say like, we'll make sure this message was signed by the right person, and then it's back to access control lists. And so the design that I was thinking about is like, whenever you deploy rholang, you can do these registry lookups where you just say like new my channel and then in parentheses backtick some URI. And it could be a public one like row registry lookup, or it could be like, you know, row my user or like my locker room lookup. And so, or actually maybe a better experience would be that you just look them up the same way with the same code, but then what happens is those names are looked for both in the public registry and in your own personal registry. So like if I have some, like the name of my wallet, for example, like I should protect that, you know, or like my capability to cast a vote or something. So what happens is I register those things, not in the global public registry, but in my own personal registry. I register that, and then when I go to deploy a transaction later, I just look it up in the registry, and since it's in my personal registry, then we're good. So the signature verification happens outside of the rholang. Like, you know, our node verifies the signature, that tells it what personal registry to look in, and then we can dig up and see whether those names are available or not.
Can you say where this private registry is located? It's also on the chain, right?
Yeah, it would also be on chain, totally, just like exactly like the current registry.
And but you're saying that only you can access this registry without signing.
With you still sign your deploy, definitely. Yeah.
No. I mean signing and proving that only you can change something inside this private registry.
Yeah, so my thought is that like when you deploy a transaction, so these blocks up here are deploys, right? Like this one and this one.
Mm-hmm.
Oh, and actually this idea doesn't need this would work also with our chain's current way of aggregating and everything. So I just think it's cool here as well. So whenever you do one of these deploy blocks, you can look up names. You can look up, so I think I'm thinking of this like a good tagline would be like, leave your crypto at the door. None of these COM events that happen further down the reductions are going to check any signatures or anything. The signature checking happens only in these kinds of deployment blocks here. And so when I sign something, when I send a transaction in, the way that the logic basically is check the signature, see what public key sent it, and now look at all the name lookups, which, by the way, can only happen as the very first step. Name lookups from the registry can't happen further down. They only happen right here in the deploy blocks. And if you try to look up any name, and it's either in the published registry or in the registry that corresponds with the key that you signed your deploy with, then you get those names. Otherwise, if those names can't be found, then the deployment fails.
Okay. So you're using the signing of your deployment as a proof for registry.
Exactly. And then everything that happens inside Row VM world is full OCAP discipline. So I'm thinking of the personal registry as just a place to like leave my unforgeable names when I'm off chain, you know, when I'm out living my life in the human world or whatever.
How do you mean that?
So, I mean, like, for example, imagine you deploy some rholang that makes like, you know, new this and new that, and these are important things that I want to keep around. And maybe as my code reduces, I use those a couple times, you know, maybe I'm like setting up some games, getting some capabilities in those games and making my first few moves. And now I've done as much as I can, and counterparties have to do some stuff, and then I'll come back later and like deploy my next moves. Well, those names that I made in that first bit of the reduction, you know, I did a bunch of new this and new that, or I called some factories that gave me back new names or something. I need to still be able to have access to those when I do another deploy later, right? Like when I come back and see what my counterparties have done and now I'm ready to make my next move. And so the way that I maintain access to those in between deployments is that I register them, in some cases maybe globally, but in this example, in my personal registry. And then the only way anyone can ever access those things from my personal registry again are by deploying something that looks them up that's signed with my correct key.
Yeah, this totally makes sense.
Yeah, so I was hoping that that would be an interesting idea. The problem is like it's so hard to code stuff like that. Yeah, for me at least.
Yeah, I'm taking this in a sense of libraries, because right, you can have your own, you can have a bunch of contracts that you have written before, right? And when you want to build another program, you want to use these other contracts, like other libraries that can be in your personal repository, and you can say, okay, I will take this contract and I will deploy it here.
Yeah,
right.
yeah. Nice.
So, do you need some special, besides besides this logic of signing deployment and using this signed key? Do you need anything else changed in rholang, or everything else will be working the same?
I mean, so I think in rholang itself, not much else changes, but in what the co-op has implemented recently, I think it really simplifies and improves what they've tried to do with wallets. Because right now they have those special, like the wallet's special in some ways, right? Like it grabs the sender of the message and compares the signature there, and then like depending on the deployer, you're either able to send rev or not, and it's sort of special cased for that wallet contract. But I'm basically saying do that same thing you did, but do it at one level higher abstraction, and then just make the wallet a consumer of that API you just built. Totally solves your OCAP problems and makes this solution available to like all the other contracts that you might deploy.
Yeah, this totally makes sense.
Yeah,
because
nice.
you're protected, right, with signing this deployment. No one else can make this deployment. This is your deployment, and you're accessing this. So yeah, but the registry is almost the same, right? In the registry is still your public key.
Yeah,
for this deployment, right?
So the implementation of the registry right now is a little bit funky, and first of all, there's the insert arbitrary part, which doesn't need any keys at all. And then there's the insert signed part, which like you need to sign with your key. But if it, at least at one point, the implementation was that like you actually submit, like it's not the key that signed the transaction. It's that you're like building your rholang, serializing just the parts that you need to sign, signing those, and then like those signed bytes of the signature go into the rholang, other parts of the rholang that you're going to deploy or something. So I think it's nice to get that out of the like, something that dApp developers and such have to like focus on.
Yeah. This simplifies things, right? If you can sign your deployment, you're done.
Exactly.
Whatever code you have written, it's your code, and all other validators can check that this is your code.
Exactly. And since they know that it's your code, they know that it's safe to give you access to whatever is registered in this particular private registry. Yeah,
signed with this public key that you're signing this exact deployment.
Yeah.
Totally makes sense.
Yeah. Yeah.
Now,
cool.
Now I'm asking why is not why now? Why is now?
I don't know. I just really want to suggest it to the right person, but I don't know who the right person is, and yeah. So, but now it's on video,
yeah.
Discoverable.
Yeah. This totally makes sense. Yeah.
Cool. Yeah. Well, thanks for listening. I'm happy to get some of those ideas sort of written down a little bit.
Yeah, and I'm willing to talk about this more. You know, I will definitely think about it. And yeah, maybe I can think about more questions about it.
Yeah, yeah, right. Cool. Nice.
Yeah.
Okay, you want to talk about anything else, or you want to call it a day?
No, I'm fine. I'm fine. But yeah, maybe we can talk about this in the same sense of this module system. How to package rolling code.
How to package rolling code?
Yeah, and how to share the code.
Yeah.
How to store the code inside your locally R node and then just transfer it to the public network code.
Yeah.
Because in a sense, I see your suggestions very in the same way. So I would definitely want to talk about this more.
Yeah, yeah, interesting. Yeah, I wonder we should like come up with a use case and then talk through it next week or whenever.
Yeah, I would like to talk about your example of I think you're calling RPM, right?
ROPM.
RPM, yeah.
Oh, sure. Yeah, we can talk
Because
about that for sure. It definitely doesn't work anymore though. It's way behind the current node version.
yeah, but I think that it is important that you somehow show what is the problematic. You know, what do you need to do to get code from registry? It's not simple. You know what you must get this whole hash and everything. You know, it
Yeah,
will be
yeah.
much easier to have some name that you can say this is
Yeah, I
my
see.
domain or name of my library. You can just say, okay,
Yeah,
give me the
yeah.
latest version. Give me this version.
Oh, yeah. So that's
For example, for a locker, you can say, give me the locker version 001. And this version 001 is translated to this long hash that you cannot remember.
oh, yeah. That's a cool idea. That allows you to
Because
like
I see
that's like
you are explaining exactly that. Sorry?
it feels like pet names a little bit, the way you described it there. Like maybe the formal name of some library is this like long hash of its code, and that's definitely a unique identifier. But I would really like to call it like mylib 1.1, not this long ass hash.
Yeah. And this is very close to what you are suggesting, to have some kind of way of
Yeah. Oh, that's a great point. Yeah.
naming or
Yeah. I mean, so RoPM also targets the concept of like libraries that can be shared, or it also targets basically like dynamic linking. So like if there's some library, some math rholang library that's super useful and I deploy it and I deploy code that uses it, and then later you deploy code that uses the same version, like it would be super nice if we didn't have to duplicate that library in the tuple space.
yeah.
And
And it would be great that you don't have to search for the whole hash.
yeah, right.
Because you know now we have a GitHub, but you don't have to specify each time the commit. You can say, okay, the username / repository branch. You don't have to work with the commits directly.
Right. Yeah. Exactly.
So this is definitely cool. Yeah.
Yeah. Cool, man. All right. Good talk. Good sesh.
Maybe we can think about this special name for this purpose, right?
Yeah. What do you mean?
I mean, if you can have this special name that can similar like a registry, that can serve the purpose of DNS or something like that.
Oh,
that can translate these names to real repository names. And
oh, that's interesting. Are you familiar with ENS, the Ethereum name service?
I heard of it, but I don't know how
yeah, it's an interesting thing. I don't remember exactly how it works, but it has some problems with like land rush, where people like grab up names and try to resell them later and stuff. But it's a kind of a cool attempt at like a pet name registry.
Cool.
Yeah.
Would you like to talk about this maybe next time? Or?
Yeah, totally. You know what? Here's a meta thought too. I want to start, I think I'm going to use the tool Lumio, but I'm not really sure, but we should have a way to like have anyone propose ideas throughout the week and then like rank them like, you know, oh, I saw Tomislav propose this and that's a great idea. I want to like upvote that. And then we kind of have this like running agenda / backlog.
Yeah, this is a good idea. Yeah.
Yeah, I'm going to work on that today.
Cool. And then maybe we can, you know, build something on ArchChain to do this voting.
Yeah. Oh, that would be great. Yeah.
But if we have a stable network, you know.
Yeah, and don't forget, I have another job now that I'm trying to focus time on too. That's new for me.
Yeah.
You do too, I guess, right? What do you do other than ArchChain?
Well, now I'm on few projects in parallel. So yeah, I'm organizing one team and yeah.
Oh, cool. Are you like a freelancer or you have a employer?
So now I'm in a company with my friend, and we are starting like different projects, and you know we're trying to build a business for that.
Oh, cool. Oh yeah, great.
And I will have something interesting maybe for next week or week after that. In C#, I'm building like a FX library. So,
oh, really? Nice. That's cool. I've never done C#.
and Java. Did you done everything Java?
I've done a lot of Java. Yeah, they're pretty similar, right?
Okay. Yeah. Totally. Yeah. Cool. I'm using like generics in more complicated way, but it's not like something that is it cannot be translated to Java.
Yeah. Cool. Okay. Well, I guess maybe we'll sign off.
Yeah.
Cool. All right. See you next time.
Nice talk.
Or tomorrow, I guess, for consensus.
Oh yeah.
All right. Cool. See you later.
Bye.